Hey guys, so this was your homework question. So let's discuss this question here. You have a disk which has uniform surface charge density in the upper part. The surface charge density is given as rho, and even in the lower half, you have a negative equal surface charge density. And this disk is placed on a rough horizontal surface as shown in figure. Right? So let me draw the surface as well. Okay, so this is a rough surface. You have a uniform electric field being set up. So this is your direction of electric field, it's towards right, as shown in figure. And mass of the disk is given, radius of the disk is given, right? And friction is sufficient to prevent slipping. So from all of these conditions, you're supposed to calculate what will be the acceleration of the disk in this case. What will it be equal to, right? Okay, so if you can already guess the approach for this question would be to convert this disk into a dipole. And that's what I'll be doing over here as well. I'll be converting this disk into a dipole right now. The entire upper half of the disk, the entire upper half of the disk is partially charged, and I can concentrate the entire upper half of the disk at its center of charge. That center of charge will coincide with the center of mass because it's a uniform charge distribution, and that distance will be equal to 4r by 3 pi. Similarly, I can concentrate the entire negative charge also at its center of charge, which will also be equal to 4r by 3 pi. So, what will be the net dipole moment of this disk? This net dipole moment of this disk will be equal to q into 8r by 3 pi, where q is the charge on each half of the disk, and that q value will be equal to nothing but rho into pi r squared by 2. So it's rho into pi r squared by 2 into 8r by 3 pi. This will be your net dipole moment, right? So pi gets cancelled, 2 gets cancelled. So we'll get this value to be equal to 4 rho r cubed by 3. So this is your dipole moment of the disk right now, right? And this disk is present inside a uniform electric. It's on a rough surface and is present inside a uniform electric field, right? So because it's a dipole, the net force on dipole due to external electric field, which is uniform as well, due to external uniform electric field, will be equal to 0. So there will be force acting on each plus q and minus q. But the net force acting on the dipole due to this external electric field will be equal to 0. Right? But there will be a torque acting on this dipole or no. So what will be the net torque acting on the dipole due to electric field? So your dipole direction is this way from minus q to plus q. Electric field is in the x-axis. So that means the angle between p bar and e bar is 90 degrees. So we'll have a torque. That torque value will be equal to P sine 90, which is equal to dipole moment value multiplied with the electric field. This is the value of P, which we'll substitute later. And what will be the direction of the torque? This will try to align the dipole along the electric field direction. So there will be a torque acting on this dipole in the clockwise direction. So you'll have a clockwise torque acting over here, right? Okay, so now we need to deal with what is the acceleration of the disk. So now this is a mechanics question once I found out all the force and torques here. So now let me describe the scenario. This is your disk. We have normal force acting on this disk. We have mg force acting on this disk. You have friction force acting on this disk as well. Right, let me assume friction is forward. So you can guess why friction is acting in the forward direction. Because net force on the dipole is 0. So the electric field will not try to push this disk forward. But the electric field will try to rotate this disk in the clockwise direction. So if you can notice, just because of electric field, if only electric field was there, there'll only be a torque acting on this disk. There'll only be a torque acting on this disk in this direction. There'll be no force acting on this disk, which means only in the presence of electric field, this disk will rotate, but it will not move forward. It will rotate in the clockwise direction, but it will not move forward, which means this point will be slipping backwards if there was no friction. So friction is present. Friction will try to prevent slipping. So friction will be acting in the forward direction over here, right? And now since we need to calculate acceleration of the disk, this is a standard combined translation and rotation equation which we'll be writing over here. So the three equations we'll be writing is net force is equal to mass into acceleration of center of mass. So let me assume acceleration is in this direction. So my equation is F is equal to ma, where a is the acceleration of center of mass. The next equation is torque equation. Torque due to electric field will be equal to P into E clockwise. So I'm assuming angular acceleration is clockwise. Torque due to friction will be in the anti-clockwise direction, so minus Fr. And that will be equal to I into alpha, which is equal to mr squared by 2 into alpha. This is our second equation. And the third equation is because there's no slipping, A has to be equal to R alpha. The acceleration of this point has to be equal to 0. So A has to cancel out with R alpha over here. And now we'll just have to solve these three equations, right? Okay, so the three equations where F is equal to ma, Pe minus F sine Fr was equal to mr squared by 2 into alpha, and A is equal to R alpha, right? So substituting A is equal to R alpha in this equation, I'll get Pe minus Fr to be equal to alpha is equal to a by r. So I'll get m r a by 2. And I have f is equal to ma over here. The aim is to find out acceleration. Friction is an unknown. So let me multiply this equation with r. So I'll get fr is equal to mar. And now let me add both these equations. So we'll get p is equal to 3mar by 2 upon adding these two equations. And we'll get acceleration to be equal to 2pe by 3mr. Substituting the value, p value was 4 rho r cubed by 3. So 2 into 4 rho r cubed by 3 into e divided by 3 mr will be our answer. So this turns out to be 8 rho r cube e by 9 mr. 1 r will get cancelled. So this will be equal to 8 rho r squared e by 9. So this will be our acceleration of the disk, right? So 8 rho. So that is your option number 1. 1 will be the answer. Hopefully this question made sense. See you guys in the next question.